Okay, this is bonus lesson number 4, and we're actually going to learn something that's a little bit of an Algebra 2 tactic, but accomplishes much of the same thing that we're doing in Algebra 1, since we just learned to factor out a GCF. And what we're going to do is learn polynomial long division and use it to find factors of polynomial. Okay, so one big idea about factoring is that if a binomial is a factor of a polynomial, then when we do long division, there will be no remainder. Okay, that's a really big idea for what a factor is. Now, I am, by the way, going to want to see that you guys did take notes on this. There's going to be an independent practice page, but I'm also going to want to see that you guys fill in the notes. Okay, so polynomial long division is really just like normal long divisions, but with x's to replace the place value of the powers of 10. Okay, so we're going to line up like terms, just the way a number in the hundreds column has to be over a number in the hundreds columns. We're going to be careful with our negatives. When you guys originally did long division, you weren't using negative. And we're going to remember what we're doing. Okay, so I'll model some examples, and we're going to see that if the binomial is a factor of a larger polynomial, there will be no remainder. So for example, if we're trying to figure out how many times does x plus 5 go into the polynomial, so the first question is, well, how many times does x plus 5 go into that first number there, okay? How many times does x plus 5 go into x cubed? Well, it would have to go in x squared times, right? X squared, right? We always, now, what I did there for the first thing is actually something wrong. I put the x squared where? On top of the x cubed. And I need to, in fact, move it over because of place value, okay? So instead, we're going to put the x squared there for correct place value, and then we are going to, like we normally do, first divide, right? Then we multiply. X squared times x is x cubed. X squared times 5 is 5x squared. Okay? Well, then the next thing we do is subtract. So 3x squared, this obviously equals 0x cubed, and then 3x squared minus 5x squared is minus 2x squared. Now, we bring down the next term, and we're ready to keep going, okay? So how many times does x go into negative 2x squared? So we obviously know that that would be negative 2x, right? Because what we're trying to do is come up with a term that when we multiply it by our binomial, that first piece is going to cancel out, right? Which is always what we're doing with long division. So now we have, when we multiply negative 2x squared, minus 10x. Now we're going to have to be so careful about our double negatives. Negative 2x times x is negative 2x squared. Negative 2x times 5 is negative 10x. This is 0. And then negative 13x minus negative 10x is really negative 13x plus 10x. So we're left with negative 3x. We bring down our minus 15. And how many times does x plus 5 go into negative 3x minus 15? Well, negative 3x divided by x is negative 3. And what happens? We do negative 3 times x is negative 3x, and negative 3 times plus 5 is negative 15. And oh my goodness, we have a 0 remainder. So what we've discovered is that x plus 5 goes into the polynomial x cubed plus 3x squared minus 13x minus 15. Exactly. X squared minus 2x minus 3 times, right? That's the quotient up on the top, right? Another way to think about that would be that we now know that if we multiply this times this, we would get our original polynomial, okay? And you guys are going to learn a lot more of the underlying math in future years. But for now, you know enough to do this, okay? So now we're going to divide, and we're going to see if there's a remainder. Okay, so how many times does x go into 2x squared? It goes in 2x times. 2x times x squared is 2x times x is 2x squared, right? We always want to get rid of that. We always want this first piece to go away, so now we're left with negative 5x. We bring down the negative 8. How many times does x go into negative 5x? We do minus 5. Negative 5 times x is negative 5x But then here we have negative 20, okay? And obviously we can tell there's going to be a remainder. X plus 4 is not a factor of the original trinomial. And what we're going to get is negative 8 minus negative 20 is going to be positive 12. So the remainder, the quotient, is 2x plus 5. And the remainder is 12, okay? Another way of thinking about it is if we were to multiply x plus 4 times 2x minus 5, the product that we would get will be 12 off from the original one we started about. But since we haven't learned to multiply those two numbers yet, we're not going to worry about that today. Okay, so the reason that this is kicking it up a notch is you may notice if I write x cubed, right, the next thing I should write under here is my x squared term. What's my x squared term? Right, I have 0x squareds. You've got to be careful about the place value. That's one of the things that makes it hard. Okay, so how many times does x minus 4 go into x cubed? X squared times. So now we have x cubed minus 4x squared. And 0, right, we're going to do 0 minus negative 4x squared. And we're going to get positive 4x squared. Bring down. And how many times does that go in there? That's going to go in 4x times. 4x times x is 4x squared plus, minus 16x. Okay, so then we're going to minus a negative again, and we're going to get negative 13x minus negative 16x is positive 3x. Bring down our negative 12, and oh my goodness, we write a plus 3 here, and all of a sudden we get 3x minus 12, and 0 remainder means it is a factor. Okay, so we have just shown that x minus 4 is a factor of x cubed minus 13x minus 12. When you multiply x minus 4 times x squared plus 4x plus 3, you get x cubed plus 0x squared minus 13x minus 12. Isn't that fantastic? Okay, now, this is tricky, A, because there's a piece missing here. Pen colors. We've got a piece missing here. Right, so we're going to have to add in our x column, just like we did last time. But there's also one other thing that's tricky, and that's that we have an x squared here. Now, we just have to be careful when we multiply. How many times does x squared go into 3x to the 4th? Well, 3x to the 4th, right, we learned how to do this. Divided by x squared would be 3x squared. So, we have to put that up here, 3x squared. So 3x squared times x squared, it gives us 3x to the 4th. 3x squared times 1 gives us 3x squared. So what do? Well, we subtract, right? That's going to be 0. What's now negative 4x cubed minus 0x cubed? Basically, this piece comes down also, right? And so we're actually not going to need to bring down yet because we can do another division before we need to bring down. Really what we're bringing down is the cubed term. So how many times does x squared go into negative 4x cubed? Negative 4x. So now we have negative 4x cubed. And now we have, careful, and 0x squared. Right? See how I almost made a mistake there? Because if I multiply negative 4x times x squared, I'm going to get a cubic term. If I multiply negative 4x times 1, I'm going to get an x term. Right? So we have 0x. So I've got to just be careful that I know what I'm doing here. Okay. So negative 4x squared minus negative 4x cubed. Negative 4x cubed minus negative 4x cubed is 0. That's what we wanted. Now we have 9x squared. And careful, double negative, 0x minus negative 4x becomes plus 4x. How many times does this go in? It actually goes in 9 times, right? 9 times 9x squared is 9x squared. And 9 times 1 is, remember that 5 is there by the way, 9 times 1 is 9. Okay, now as we can tell, we've got, almost by definition sort of got a remainder just because of the way we work. It's never completely canceling out. So obviously x squared plus 1 is not a factor of that big polynomial. We have a quotient, 3x squared minus 4x plus 9, and now we just have to find our remainder, and we have 4x minus 0 is 4x, and then 5 minus 9 is minus 4. So that's our remainder. If we divide, that's what's left over. Okay. We're not going to get through all of this in 15 minutes, but it is worth taking the time to do it yourself. One of the things I'm going to do to make sure we can get more done is I'm going to pause the video and I'm going to see, I'm taking time to set this up. And I'm going to do the long division myself, okay? So what I want you to do is pause the video and then unpause it when you're ready to see what to compare your answer to mine. Okay, so I've done about half of my long division, and I saw that x to the power 4 goes into x to the power 5, x times. So then I multiply it back out, and I've got x to the power 5 times minus x. Then I start subtracting, and I get 5x to the 4th. Everything's a 0 here, right? Even that, 0x cubed, 0x squared, 0x minus 5. So all of a sudden, how many times does x to the power 4th go into 5x to the power 4th? Well, plus 5. Right? Plus 5 times x to the power 4th is 5x to the power 4th. And all of a sudden, I got a minus 5. So even though this might have looked to us initially like it was not, the answer is yes, because we divide it and there's no remainder. Because all of those other missing pieces, we don't have to worry too much about them, although we didn't know that when we started, right? Okay, so let's go on. So we can do the exact same thing here. I'm going to set it up, and you'll see the answer in a second. So maybe you took one look at this and said, no way can it be a factor. 57 is a ridiculous number. Well, we got to figure that out first. But x minus 7 goes into x cubed, x squared times. And then when we multiply that out, we get a negative 7x squared. And 0 minus negative 7 is actually 7x squared minus 57x. So then all of a sudden, we have a plus 7x over here. And that gives us 7x squared minus 49x. And now we just have to not mess up our subtraction, because negative 57 plus 49, right, because it's minus negative, will give us 8x. And now we have 8x plus 56. Interesting. How many times does x go into 8x? 8. And when we multiply this out, we get 8x minus 56. So does it work? Nope, because the sign is wrong. If that had been a minus 56, it totally would have been a factor. But because it is not a minus 56, we have a remainder of 112. So it is not a factor. Okay. What about x plus 7? So you may have a hunch that these numbers are going to work very similarly to the way they did in the last one. So pause the video and work it out and see what you get. Okay, so I did this in stages, but if you'll see, we started with the same x squared, and then because we had a negative 7x here, and we brought down the negative 59x, we just put a negative up here, negative 7x. Right? If you look on the previous page, it actually had been positive 7x. And then here we have the same numbers coming out, because it's a negative 57x brought down, that becomes an 8x, and the numbers work. And in fact, x plus 7 is a factor. Yes, yes, yes. Okay. So there's this example, and this example, which I'll do in a second, and this example. And then ultimately, you can keep watching if you want to see it, but ultimately I'd like to see if you can do, if any of these factors is whether any of these binomials are factors of that. Okay? And for the top, it's a yes or a no, and it's give the remainder. And the hint is you shouldn't need to do any extra work, because these are sort of much easier examples. And in theory, when you find the division, you will find the remainder. So on the bottom part, you should just write what the remainder is. Okay, so I have given you to do a couple tricky ones. And so yeah, page 10, page 11, and page 12 tricky ones. And then 4 easier ones. Good luck with that. Have a great day.